Hello, Dr. Mayer. This is Ali. I'm doing a physics problem today from energy conservation, and our problem today is going to be something like a 2 kilogram block is pushed against a spring with a negligible mass and force constant K 400 newtons over meter, compressing it some distance. When the block is released, it moves along frictionless horizontal surface. So from this situation, we could draw a diagram, something like that, where we have a block and a spring, and it's going to be compressed when the block is being pushed. The spring is going to be compressed some distance, and we have a spring constant which is 400 newtons over meter. And the third scenario would be something like that, where we had after we had the compress position, something over here to over here, and then there was some energy conserved on the spring, and the spring is going to release the energy on the block, is going to slide horizontally some distance with some velocity as well. And our final question comes out to be is, what is the speed of the block as it slides along the horizontal surface after having left the spring? So from here, it's going to move some distance with some velocity, and we know our known and unknown values here. And with the way we could solve that is, we know there's work done on the spring and also work done on the object, work done on the spring and the object. So if we write the equation separately, we could say that work done on the block is going to be the change of kinetic energy, which is 1/2 mv2 squared minus 1/2 mv1 squared, and work done on the spring also is 1/2 kx2 squared minus kx1 squared. So if we set them up equal to each other and try to find the final velocity, we know all of them has 1/2, so we could just cancel them out. And then we also know that initial velocity is 0, also initial position is 0, so we could say that this whole thing becomes 0, so we could just cancel these two out, and then we are finally left with the mass times the final velocity equals to the constant and the final compressed position to the second power. So if we plug in all these values for mass and the constant K, also the compressed distance, we have the final velocity square equals to the 19.36 divided by 2, and the velocity is going to be square root of 19.36 divided by 2, and our final velocity comes out to be 3.11 meters per second. And this would be the velocity that the block moves along the horizontal surface. Thank you so much.